Welcome to Chapter 10, Section 6, Segment Relationships in Circles. The essential question is, what relationships exist among the segments formed by two intersecting chords or among segments of two secants that intersect outside a circle? What you will learn is how to use segments of chords, tangents, and secants. So we're starting off with the theorem, the segments of chords theorem. So if I have two chords that intersect in the interior of a circle, so let's say I have this chord CD intersecting chord AB. So that's what the first part of this theorem is saying. So if I have that, then the product of the lengths of the segment of one chord is equal to the product of the lengths of the segments of another chord. So we're talking about products. So we're going to be multiplying something. So what we're going to be multiplying is we're going to take a piece of one chord, so let's say EA, and we're going to multiply that by the second piece of that same chord, EB. Now that is going to be equal to the other segments of the other chord, so EC times ED. Okay, and that is the segment of chords theorem. All right, so we're going to use that to apply it to this problem here. Now, this is going to be probably the hardest type of problem that we're going to face, and I wanted to include that here so that you guys are able to see it. Now, the problems that you guys are going to have in the practice are probably going to be a lot easier than this, so you can do it a lot quicker. But I'm choosing to do the hardest one so that you guys can all see what's going on and how to solve something like this. But we use the same concept. So if I take this segment here, okay, so I'm going to take X, and I'm going to multiply that by the other piece of that same chord. So I'm going to multiply it times this, and that is X plus 4. All right, so I'm going to multiply that times X plus 4, and that's going to be equal to, and this might not fit, let me rewrite it. Let's put it down here. So we had X, and we're multiplying that times X plus 4. All right, and then that's going to be equal to our other two segments of the other chord. So let's say this piece right here, X plus 1 times X plus 2. All right, so then once we multiply, we're going to get something that is a quadratic. So if we multiply these two here, X times X is X squared. X times 4 is 4X. That's going to be equal to X times X, X squared. X times 2 is 2X. 1 times X is 1X. 1 times 2 is 2. So I'm going to go ahead and simplify this. I'm going to keep X squared plus 4X over here. That's going to be equal to X squared plus 3X plus 2. And all I did is combine like terms, so those two right there. And now what I'm going to do is I'm going to be subtracting like terms, getting them on the same side of each other. So I'm going to subtract X squared with this X squared. I'm going to move everything all at once. I'm going to move this 4X over here with this. All right. So then, boom, that cancels out. This cancels out. This cancels out. So that means that on this left side over here, we're going to actually have 0. So 0 equals negative 1X plus 2. Okay, so then I'm going to go ahead and move the X back to the other side. So I can leave the X by itself and find out what X is. So I'm going to add 1X. So then that's going to give me X is equal to positive 2. All right, so that is the start of it. So we have x is equal to positive 2. Now, the question is not asking for the value of x. That question is asking for the measure of a segment. So we're looking for ML. So from M to L. So what we have to do is then we have to substitute. So I'm going to go ahead and erase this piece right here so that I may find the measure of ML. So ML, so first I want to find each part of the segment. So I have x plus 1, x plus 2. If x is 2, this is 2 plus 2. So this piece up here is 4. If x is 2, this is 2 plus 1. So this is 3. So then the whole segment is 4 plus 3, or 7. Okay. And then we're going to find the measure of segment JK, which is from here to here, JK. We're going to need x and x plus 4. So if x is 2, then here, this piece right here is 2. And then this is 2 plus 4, which is 6. So then I have 2 plus 6, which is JK. The whole JK is 8. All right, so we're going to talk about the segments of secants theorem. But first, we're going to talk about some key vocabulary that we're going to talk about. So a tangent segment is a segment. So remember, segment means part. So part of a tangent that is tangent to a circle at an endpoint. So this is a tangent segment. Okay, it's not it's not just a regular tangent, because remember, a tangent could go on forever on one direction or another, or both, but this is just a piece of it, so we're going to call that a tangent segment. A secant segment is also just a part of a secant, where it contains a chord of a circle, so this is the chord of a circle, and exactly one endpoint outside of the circle, so from here to the outside. So it doesn't have anything else on the other end of the segment. And the last part is the part of the segment, of the secant segment, so the part of this red line that I drew that is outside of the circle, so this piece right here from P to Q, that is called the external segment. All right, so we're going to use these terms to define some things in our theorem. So our theorem states, if two secant segments share the same endpoint outside of a circle, so here on the image, I have a secant segment and another secant segment here, okay, and they intersect exactly at one point E. So we have that. Then the product of the length of one secant segment, so if I take one secant segment, so from E to B, and I multiply that, I find the product of that and its external segment. So the external segment of this blue line is from E to A. So if I multiply those two, then that's going to be equal to our other secant segment times that secant segment's external segment, which is EC. All right, so that is our segments of secant theorem. Okay, so we're going to do this right here. So we have here two secant segments. Secant because it intersects the circle twice, and it's part of it is outside the circle, 1, 2. And so what we're going to do here is we're going to use that theorem that we just learned in the previous slide. So what happens here is we want to take one secant. How long is this? So this whole thing is actually 20, 9 plus 11. So I'm going to have 20 times the measure of its exterior secant. So just this piece here, so 9. So 20 times 9. And I'm going to set that equal to the other secant segment. I'm going to do that. This is going to be all of that. So the whole thing is 10 plus x. Now we we don't know what x is, so I'm going to write it as 10 plus x. And then I'm going to multiply that by its external segment, which is 10. So times 10. So I'm just going to start simplifying everything. So then this is 180 is equal to 100 plus 10x. Okay, so here I'm going to start subtracting. So I'm going to subtract 100. Let's do it in a different color. I'm going to leave the x by itself because that's what we're looking for. We're looking for the value of x. So I'm subtracting 100 from both sides. That's not going to cancel. And then I'm bringing everything else down. So I have 10x, that's what's left over, is equal to 80. And then I just divide both sides by 10. X equals 8. Next theorem, segments of secant and tangent theorem. So if a secant segment and a tangent segment share an endpoint outside of a circle, so now this is not two secants anymore. This is a tangent, right? Touches the circle only one time, and it's a segment of it, and a secant segment intersect outside of a circle, so they're intersecting at this angle E at one point. Then the product of the lengths of a secant segment and its external segment, so we want to multiply the whole thing, so the whole secant segment times its external segment EC is going to be equal to the external segment equal to the square of the length of the tangent segment. So you're going to take the tangent segment and raise it to the second power. Okay, so let's actually use that theorem here. So what we want is we want our tangent is going to be squared. So 16 squared is equal to our secant segment. So that's going to be x plus 8 multiplied by the external segment, which in this case is red, external segment, which is x. Okay, so then we're going to go ahead and solve this one out. We're going to do 16 to the power of 2. It's 256. 256 is equal to x times x squared, x times 8, 8x. Okay, so it looks like this is going to be a quadratic equation, so I'm going to have to write this in standard form. So minus 256 minus 256. I can't solve it because there's still an x squared, so I have to use something different. So this is going to be 0 equals to x squared plus 8x minus 256. Okay, so now this is a quadratic equation. Now what we're going to be remembering is the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So I'm going to go ahead and identify a, b, and c so that we can substitute it into the quadratic formula. So a is the number in front of the x squared, if we recall. So that's going to be 1. B is the one in front of the x term, so 8. And c is the constant term, or negative 256. Okay, so I'm going to go ahead and pull up the calculator right here. And I'm going to write our quadratic formula. So it goes, well, I forgot the negative sign already. Let's do this. X is equal to negative b. So because there's no plus or minus sign in here, I'm actually going to do plus first, and then I'll change it to minus. And it's easy to change. I'll show you. Plus or minus the square root of b squared minus 4 times a times c. And then we're going to divide all of this all over 2 times a. All right, so this is the quadratic formula, and obviously it's giving us a warning because it can't really solve this. So what I'm going to do is I'm going to come back here and I'm going to change all the letters to the numbers that we found over here. So all the b's are going to be 8s. My a's are going to be 1s. Oops. Remember, this has got to be multiplying. So parentheses 1. And then this, the 1 over here. And then the C is a negative 256. All right, so check this out. So we've substituted these values of the quadratic into the quadratic formula, and it gives us 12.49. So let's write that down. So we have 12.49. Let's round to the hundredth, so let's leave it at 12.49. But remember, the quadratic formula is negative b plus or minus. So I'm going to take this and I'm going to put the minus, erase the plus, I erase the plus, and added a subtraction symbol. So then I get negative 2049. Okay, and then this is where you're going to use some logic and think about which one of these is the actual answer. So this is C. Oops. So what do I mean by which one is the actual answer? Well, only one of these could be the answer because we're looking for this value of x. So which one could it actually be? And the only one that makes actual sense is the positive one. We want to take the positive one because there's no way that something can measure a negative measure. So think about like when you're measuring using a ruler, like you never say something is like negative 20.49 inches. Like that's not correct. So our correct answer here is 12.49. Boom. And that's it. Okay, so what you should have learned in this section is how to use a segment of Chords' theorem, okay, to find the value of x. You should have learned the segments of Secant's theorem, and then how to use the segments of secants and tangents to find the value of a missing piece. Okay, I hope you learned a lot, and please leave a comment or a question in the comments down below, and I will see you next time.